Okay, now it's recording. Okay, perfect. All right. Yeah, polynomial functions. So as I said, the goal of this section is to graph polynomial functions, right? So first, I'm going to remind you what's a polynomial function, right? Very quickly. So just to remind you the definition. So a polynomial function f of x so that's is a function of the form so f of x. I mean, the idea is that polynomial function is just a combination of powers of x, but the powers of x must be whole numbers, actually positive whole numbers or zero. Okay, so so we have like some x to the power n. Okay, and in front of this x to the power n, there is some number called the leading coefficient. So the a subscript n. All right. Then after that, of course, the power of x is going to decrease, right? So we have, let's say, n to the power n, so n minus 1. And here in front of x to the power n minus 1, there is some number. Let's call this number a subscript n minus 1, etc. Plus, and then you have like x, okay, to the power 1 here, and in front of x there's a to the subscript 1, and then there's the constant a0. Okay, so again, the idea is that so n this is a positive or 0 integer. Again, by integer, I mean a whole number. Okay, and so this n, again, this is the highest power of x, right? That's the highest power of x, and it's called the degree of f. So n is called the degree of f of x. Okay, and the coefficient or the the number in front of x to the power n, this number right here, a subscript n, it's called the leading coefficient. Okay, so a subscript n is called the leading coefficient. All right. So yeah, that's for the definition of polynomial. As I said, so the goal of this section is to graph. So what we want to do, we want to graph polynomial functions. All right. So I mean, as we discussed Wednesday last week, so the simplest examples of polynomials are constant functions. We have also linear functions. So linear functions when the highest power of x is 1. And then we have quadratic functions, right? And graphs of quadratic functions are actually parabolas, right? Then the question, of course, is how to graph polynomials of degree larger or equal to 3. Right. So first, we discussed the behavior of polynomials at infinity. Right. So first, so we have the behavior of polynomials at infinity. So we're going to use this to graph, of course, polynomial functions so at infinity. All right. So, and then we said there are like 4 cases. So that when the degree is even, degree n is even, and when the degree is odd, right? And also when the leading coefficient is positive or negative. So leading coefficient is positive, and then when it's negative. Is negative. So we have these 4 cases, and then we said, so at infinity, the graph of f, so it's going to depend on the, of course, if the degree is even or odd, and it's going to depend on the sign of the leading coefficient, right? So, so we have these 4 cases. So when the degree is even and leading coefficient is positive, we said the behavior at infinity of the graph is going to look like the following. When the degree is even and the leading coefficient is negative, we're going to have something which looks like this. Degree is odd and leading coefficient is positive, we're going to have something like this. Okay, and the last case, when the degree is odd and leading coefficient is negative, you're going to start from the top right here, and you end up in the bottom here. All right, so this was discussed last week. Okay, so this was done Wednesday last week. Okay, and then so we started discussion about how to solve, how to find the x-intercepts, right? That's like the second step to graph those polynomial functions, right? So we said we need to find the x-intercepts, and to find the x-intercepts, we said we need to solve f of x equal to 0. Okay. Now, I think we had a couple of examples, but we didn't finish. So we had an exercise, I think, Wednesday last week, and we didn't. I think I didn't have time to go over the exercise. So I'm gonna just remind you. So the exercise. So we had to find the x-intercept, of course. X-intercept. So again, guys, what I mean by x-intercept, that's the intersection of the graph with the x-axis, and the way to find the x-intercept is to solve. We need to solve the f of x equal to 0. All right. So yeah. So we had. Well, I'm not sure about if this is like the first function, but so first we had like f of x. I think it was minus 2x to the fifth plus 5x to the fourth, and then minus 3x cubed. Okay, that's like first function, I think. Anyway, so again, so we need to find the x-intercept, right? So then we said, well, we need to solve f of x equal to 0. So we need to solve this minus 2x to the fifth plus 5x to the fourth minus 3x cubed, right, equal to 0. So we need to solve for x, of course. So we said, the first thing we can try is to find a common factor. The question here, is there a common factor to all these terms? As you can see, there's an x in here, there's an x in here, there's an x in here. So x would be a common factor. But actually, you can do better than x. As you can see, there is a x cubed in each of these factors. So for like here, as you can see, there's x to the fifth. So there's an x in cube there. This is an x to the fourth, and this is x cubed. So x cubed would be a common factor. So you can pull out the x cubed. All right, so that's x cubed times. So if you pull out x cubed, this is x to the fifth, right? Power 5. So so then you're left with x squared, right? Power 2. right? This is x squared because, when you multiply, you have the same base, then you have to add the powers, right? 3 plus 2, that would be 5. And then there's minus 2, of course, don't forget the minus 2. So here's my minus 2, right? And then plus, there's this plus 5. This is x to the power 4. So if you pull out 3, then you are left with x to the power 1, right? This is x power 1. Okay, minus 3 times, 3 times x cubed. So it's just minus 3 equal to 0, right? So why do we factorize, guys? I mean, the idea here, when you factorize, you get like a product, right? You have, as you can see, you have this factor times, because it's a multiplication, right? Times this second factor, right? And if you have like a product of two factors, or you think of the factors as numbers, you have a product of two numbers equal to 0, then one of the numbers is 0. Okay, that's why we factorize. That's why we bother ourselves to factorize, our polynomial. So then you can reduce your equation into like two different equations. So the first factor, so either the first factor is 0, so either the x cubed is 0. That's my first factor, right? This is my first factor. And here, this is my second factor. So either the x cubed is 0, or of course the second factor is 0. So that will be minus 2x squared plus 5x minus 3 equal to 0. All right. Well, let's solve x cubed equal to 0. X cubed equal to 0. You can just apply the third root to get rid of the cube. All right, so I'm going to apply the third root both sides. Here's the third root both sides, right? And because 0 times 0 times 0 is 0, then the third root of 0 is just 0. So then x, so this third root cancel out with the cube. So that's x, just x equal to 0. Okay. So let me just say one word here, guys. You see, this is x cubed. So when I say x cubed equal to 0, you have x cubed equal to 0, right? So x cubed is like x times x times x equal to 0, right? So it's like a product, as you can see, of 3 x's equal to 0. So it means that either the first x is 0, second x is 0, or the third x is 0. All right. And so this means actually, because it's a 3 x's, you have 3 x's, right? Equal to 0. It means that actually x equal to 0 is 3 times solution to this problem. It's not just one time, because it's not just one x equal to 0. It's like 3 x's equal to 0. So because it's x cubed equal to 0, I mean, as I said, with the cube, you're supposed to get like 3 different solutions, right? Remember what I said last week. So we have a polynomial, like the highest power of x is 5, then you expect like to have like 5 solutions, right? Or if you have like a x cubed polynomial of degree 3, then you're expect to have like 3 different solutions, right? But here, that's kind of weird here, because we have x cubed equal to 0, but then we end up with only one solution, right? And that's because x, as you can see, it's x multiplied by itself 3 times, right? So x here is like 3x equal to 0 is like, it's like 3 times solution, right? It's not just one time solution, it's like 3 times solution, right? So let me just write it down here. So x equal to 0, this is like 3 times solution of the problem, or of the equation. Okay. All right, so that's our, anyway, so this is our first, that's our first solution, x equal to 0. And then there's a second equation, right? This minus 2x squared plus 5x minus 3 equal to 0. And that's, of course, because the highest power of highest power of x is 2. So that's a quadratic equation, right? Because, well, the highest power of x is 2. So because the degree is 2. Right? So then we can just apply quadratic formula. So this is, then x, it's minus b, plus or minus square root of b squared minus 4ac over the whole thing divided by 2a. Okay. So as you can see, guys, in a quadratic formula, you have this plus or minus because, well, it's quadratic, right? So the highest power of x is 2. So in general, you're supposed to get like 2 different solutions, right? But sometimes the square root, this square root here, it's just 0. So then you end up with only 1 solution, right? But anyway, so in this case, let's see how many solutions we have. So it's minus b, so it's minus 5, right? Plus or minus square root. B squared, b is, again, it's 5. Right, this is our b. B squared, that's 5 squared, that would be 25. So here's my 25 minus, of course, 4 times a. A is -2, don't forget the negative. So a is 4 times a, -2, times, oops, times the c, and the c is -3. So this is -3 over the whole thing over 2a. So 2 times the -2. All right, so so here it's -2 times -3. So negative times negative, that would be a plus, right? So it's so your x is -5 plus or minus square root of so 25 minus 4 times 2 times 3, that will be 8 times 3, that's 24, over the whole thing, again, divided by 2a, the -4. So it's -5 plus or minus 25 minus 24, of course, that's the square root of 1 over -4. So then x is -5 minus or plus the square root of 1, of course, just 1, because 1 times 1 is 1. So plus or minus 1, the whole thing divided by -4. So we got 2 different solutions, right? So first solution, so x is -5 plus 1 over -4. So that'll be -4 over -4. That'll be +1. Okay, so that's our first solution, right? Or x, so if you subtract, that's -6 over -4. So if you reduce your fraction, of course, first, well, this is negative over negative, so it's positive, and you can reduce your fraction by dividing by 2, the top and the bottom by 2. So there'll be 3/2, right? So this is 3 over 2. So that's your second solution. So yeah, so in total, guys, we got, so we have first, we have the x equal to 0, but remember, x equal to 0, it's not just 1-time solution, it's actually 3 times solution. It counts for 3 solutions, right? Because of the x cube equal to 0. And then we have this 1, it's just 1-time solution, and the 3/2, right? It's also 1-time solution. So the answer, anyway, so the answer would be, so the x-intercepts are, so first we got the 0. So that's 0, 0. Don't forget, it's the y coordinate is always 0 in the x-intercept. And then we have 1, and then we have the 3/2. Okay. So before the next function, guys, or next problem, let me just say here again, I want to just remind you that this x equals to 0, it's x equals to 0 is actually 3 times solution to the problem. Okay. Any question, guys, about this example? All right. I think we had another function f with x to the 4th. Yeah, so I think we had, so number 2, I think we had x to the 4th minus 3x cubed plus 2x squared, right? If I'm not mistaken. So yeah, and again, the question is to find the, as usual, the x-intercept. Okay, so yeah, the highest power of x here, guys, is 4. So x to the 4th, right? So we expect to have like 4 different solutions. Okay, but let's see at the end how many solutions we're gonna get. So we need to solve as usual. Yes. Is there a question? Okay, probably not. So yeah, let's solve x to the 4th minus 3x cubed plus 2x squared equal to 0. So as I said, we need to find first, try to find, because sometimes it's not possible to have a common factor. That would be probably my next example. So the first step, we need to try to find a common factor. And here there is a common factor because, as you can see, there's an x in each term. In the first term, there's an x. In the second term, there's an x. And there's an x in the last term. So x is a common factor. We can pull out the x. But actually, we can do better than x. We can have x squared as a common factor because there's an x squared here. There is an x squared in x cubed, and there's an x squared in x to the 4th. So we can put out the x squared times, that will be, so this is x to the 4th. So we need to multiply x squared by x squared because 2 plus 2, that will be 4. And then there's this minus 3x, right? Because x times x squared, that will be 1 plus 2, that will be x cubed, and plus 2. So if you take out the x squared, you are only left with 2. So that's plus 2 equal to 0. All right, so the idea here is the same as the previous example, guys. So because we factorized our polynomial, now we have like a product. And once we have a product equal to 0, so this is a multiplication, right? This is a multiplication. So once we have a product equal to 0, product of 2 factors, then either the first factor, this is my first factor, and this is my second factor. So again, either the first factor is 0 or the second factor is 0. So either the x squared is 0, or again, this x squared minus 3x plus 2 is 0. All right, guys, so for x squared, again, the same, we have the same thing here as in the previous example. As you can see, this is a square and a equal to 0. So we are supposed in general to have like 2 different solutions. But here, if you apply, of course, if you apply the square root both sides, you apply square root. There's a square root, and there's a square root here. Don't forget, because it's an even power, there's a plus. They're supposed to have like a plus or minus. But here it doesn't matter that plus or minus because it's 0. I mean, plus or minus 0 is just 0. But yeah, so then x is just 0. All right. Now, because the power of x is 2, then here actually x equal to 0, it's actually 2 times solution of this problem. It's not just 1 time, it's 2 times solution, right? Because this is like x times x, right? Equal to 0, x squared. That's like x times x. So x equal to 0, it's actually 2 times solution, right? The first time and the second time. All right, so this is 2 times solution of the problem. It's like it counts for like two solutions, not just one. It's only one, but it counts like for 2, right? So it's 2 times solution of the problem, or of the equation. All right, and then there's this, x squared minus the x plus 2. So this is a quadratic equation because the highest power of x is 2. So this is a quadratic equation, quadratic. So then we can just apply the quadratic formula, right? So this is, then your x minus b, that will be minus negative 3, plus or minus square root of b squared. That would be negative 3 squared. That would be 9 minus 4 times a. A is, what's a? It's 1, right? Just 1. So times 1 times the c, which is positive 2. The whole thing divided by 2a. All right, so then x is minus negative 3, so that'll be plus 3, right? This is minus, that'll be a plus. So that's positive 3 plus or minus square root of 9 minus 8. That'll be 1, square root of 1, it's 1. So that's 3 plus or minus 1 over the whole thing divided by 2. So there will be 2 solutions, right? So either x is 3 plus 1 over 2. So that'll be 4 over 2. So that's 2. That's my first solution of this quadratic equation, right? Or x is 3 minus 2 over 2. So it's just 1. All right, so as you can see, it's an x squared. It's a quadratic equation, right? And I got actually two different answers, right? So each answer is just 1 time solution of the problem, okay? So yeah, so the final answer, we got, so the x-intercepts are, so first 0. But as I said, this is a 2 times solution, right? This is 2 times solution. It counts for 2 solutions, right? 2 times solution of the problem. And actually, we say that 0 here is of multiplicity 2. So we say that this solution, the x equal to 0, is of multiplicity 2. It's of multiplicity 2 because Beijing, you have a question?
Yeah, when you said like 2 times solution of the equation, that's what I don't understand.
Yeah, 2 times solution means so we have x squared equal to 0, right? And because it's a square, in theory, you're supposed to have like 2 different answers, right? As I said, like if you have like x to the x cubed, you're supposed to get like 3 different solutions. If you have like x fourth, you're supposed to have 4 solutions, etc. Right? So we have x squared equal to 0. It's a square, However, when you solve the problem, I mean, you solve x squared equal to 0, you end up with only one solution, which is just 0, right? Okay, but this x equal to 0, it counts for two solutions, because x squared, it's like x times x. So because it's x times x, so then x equal to 0, it's actually 2 times solution. It's not just 1 time, it's 2 times. You have this x supposed to be equal to 0, and this x is also supposed to be equal to 0. So it's 2 times solution because the power is 2. The power of your solution is 2. Okay.
Okay, so then if it was cubed, then it's gonna be 3, right?
Yep. If it was like x cubed equal to 0, because it's like x times x times x, that would be 3 times solution of the problem. Yeah, because it's just because of the power.
Okay.
Okay. And actually, there's a terminology for that. So because it's a 2 times solution, we say it's of multiplicity 2. All right. And then, so we have the 0 first solution. We got the x equal to 2. So then we have this is so 2, 0, and well, of course, 2, 0 is just 1 time solution. So this is of multiplicity 1. Okay, it's just 1 time solution. And then there's a 1, 0. The last solution is 1, so it's 1, 0. And it's also of multiplicity 1. We don't have any power here. So this is just power 1 of multiplicity 1. All right, and then I think there's a last example, or last problem with x cubed plus 7x squared minus 4x minus 28. Right, this is where we do the partial factor. Last function f. So we had f of x. It's x cubed plus 7x squared minus 4x minus 28. Right? And of course, we need to find the x-intercept. So yeah, so we need to solve x cubed plus 7x squared minus 4x minus 28 equal to 0. All right, guys. So of course here, I mean, the highest power of x is 3. This is not a quadratic equation, right? We can not just use the quadratic formula. So then we need to try to find the common factor. As you can see in this problem, x is not really a common factor. Well, there's an x in here, there's an x in here, there's an x in here, but there's no x in here, right? In the last term here, there's no x. Okay, so then x is not a common factor. So we cannot really factor out x. However, so x is not a common factor. So next thing we can try to do is a partial factoring, right? So partial factoring, right? So what we can do is instead of factoring the whole function f or the whole polynomial, I'm gonna just take 2 or 3 terms of the function f or of the polynomial and try to factor it. So for example, if you take so this is, again, let me write down again the polynomial. So this is x cubed plus 7x squared minus 4x, right, minus 28 equals 0. So I'm gonna take, for example, the first 2 terms, the x cubed and the 7x squared, and I'm gonna factor it. Okay. You can take different terms, guys. You don't have to take the first and the second. I can take, for example, instead of x cubed plus 7x squared, I can try, for example, we can try, x cubed and the 4x. Okay, it doesn't have to be the, the first and the second. It can be the first and the third. You can take the first and the last, etc. Okay. So let's just try the first and the second and see if it's gonna work or not. Okay. So if you just take the first and the second terms, so here's my first and the second. You can see x is a common factor, not just x, actually, x squared. So we can factor out the x squared. Then you're left with, so it's x cubed, so it's x in here, plus there's a 7x squared. So you take out x squared, so you're left with 7. All right. So I factored the first and the second terms. Now I'm gonna try to factor the third and the fourth. So the third, it's minus 4x. Third term is minus 4x, and the fourth term is minus or negative 28. Right? That's what I have. Or no, it's not. Sorry, it's not minus. Sorry, it's minus x plus. Sorry, this is minus x plus 4. This is a different example. Sorry, I think I did this. It's plus 4, minus x plus 4. Sorry about that. It's minus x plus 4. So this is minus x plus 4. So it's supposed to be the 4x squared, actually. Sorry, I think I did this example. The one we had in the exercise is different. I'm sorry about that, guys. So it's actually minus x cubed. Let me, yeah, minus 4x squared. Sorry. So in the exercise, I mean, I did this as example, but in the exercise we had x cubed minus 4x squared. This is minus 4x squared, right? And then we had like minus x plus 4. Okay, so we need to solve. It's 4. I mean, that's just the same. It's the same, same idea. I mean, we're gonna apply the same trick, the partial fraction. So yeah, equal to 0. So as I said, we're gonna factor the first 2 terms. Okay, so this x cubed minus 4x squared, and again the x squared would be a common factor, so that would be x minus 4, right? And then for the third and the fourth term here, guys, minus x plus 4. All right, so here, I mean, as you can see here, there's, I mean, it doesn't look like there's a common factor, right? It's minus x plus 4. But the thing is, as you can see here in the first and the second factor, we got this x minus 4, okay? So x minus 4, and this is minus x plus 4, it looks almost the same thing, right? So the idea is, because it's a minus x, I'm gonna just pull out minus 1. Okay, so minus x, it means it's minus or negative 1 times x, right? So this is like negative 1 times x. So I'm gonna just pull out the negative 1. So here's my negative 1 times, negative 1 times x, that will be minus x. And then because here it's a plus, right? So if you pull out negative 1, then we're gonna have minus 4 inside the parentheses, right? Because, you know, negative times negative, it's positive. When you distribute the sign, negative times negative, that'll be plus 4. Okay, and now, as you can see, I got this x minus 4 as a common factor. There's an x minus 4 here and x minus 4 here, right? Because I put out the negative 1. Okay, so once you have x minus 4 as a common factor, then you can factor out this x minus 4.
Professor, I have a question.
Yes, yeah, please. Yeah.
-1 times -4, that's supposed to be plus, right?
Yeah, -1 times -1, that's supposed to be positive. Yeah, that's exactly like minus or -1 times the negative 4. That's a positive 4.
Okay, so why you still have negative in there?
Where? The negative x?
No, x -4.
Yeah, x minus 4, because I put out -1, right? So there's this negative times this negative. So that's why we have plus 4. Okay, negative times negative will be plus 4.
Oh, good. Got.
Okay. Mm-hmm. And yeah, so now x minus 4 is a common factor. So you put out the x minus 4 times. So if you put out x minus 4, then you're left with x squared in the first term, right? So here's my x squared. Now, if you put out this x minus 4 right here, then you are left with this negative -1 or -1, right? This one right here. Okay, so here, this is -1. Okay, equal to 0. Now, because we have a product, then so this is a product, right? This is a product of 2 factors. This is my first factor, and this is my second factor. Okay. So then, yeah, so then, so either the x minus 4 is 0, or x squared minus 1 is 0. So yeah, how many solutions we are supposed to get, guys? Because remember the equation was x cubed, minus 4x, except minus 4x squared, etc. So the highest power of x is 3. So at the end, we're supposed to get like 3 different solutions, right? Now, x minus 4 equal to 0, that will be, of course, then x will be 4. Okay. And this is just one-time solution. I mean, there's no power here, as you can see. For the second one, this is x squared minus 1. So because it's x squared, right, they're supposed to have 2 solutions. Now, let's see how many solutions we're going to get. So x squared equal to positive 1. Yeah. So 3 solutions. Yeah. So this is the x equal to 4 is my first. Now x squared equal to 1. You apply the square root. So then you apply the square root, and of course, because it's an even power, then you need the plus or minus. So here, because of the square, because the power is even, you need the plus or minus. Okay. And the plus or minus here are really important, guys, because then you're gonna have 2 solutions. So then x. So of course, square root of 1 it's 1. 1 times 1 is 1. So then x is positive 1, or x is negative 1. Okay. So yeah. So in total, we have 3 different solutions, as expected, right? So each solution is just it's just one time. Each solution is just one-time solution. So yeah. So we got our 3 solutions. Each solution is just one-time solution. So the answer here, so the x-intercepts are, so first we have 4, 0. And this is just one-time solution, or multiplicity 1, just one-time solution. All right, multiplicity is 1. Is 1. The same thing for positive 1. It's one-time solution, so this is multiplicity 1. And also negative 1, it's also one-time solution. So this is also multiplicity 1. Yeah, so that's the yeah, so that's the exercise from the I guess from the Wednesday last week. I see there are some questions in the chat. Let's see. No, okay, perfect. All right, guys. So that's for the x-intercept. Now, yeah, so we need this notion of multiplicity. I mean, I need to probably discuss more examples and see, try to find the multiplicity of the x-intercepts. So yeah, so this notion of multiplicity is actually it's defined by the following. So so the multiplicity of an x-intercept, let's say, so the multiplicity of an x-intercept it's just the number of times is the number of times the x-intercept is a solution of f of x. Is a solution of f of x equal to 0. Okay. So for examples, as I said, I mean, so examples. So if you have like, you know, x squared or x cubed equal to 0, right? Then x here, of course, you apply the third root. So x is going to be equal to 0. But this is a 3 times solution because the power of x is 3. Okay, because the power is 3. So then this is a 3 times solution. So x equal to 0 is of multiplicity 3. Okay. Now instead of x cubed, you can have, for example, let's say x minus 1. So you have like x minus 1 cubed equal to 0. Okay. Well, if you have x minus cube, the whole thing, equal to 0. If you wanna solve this, all you have to do, guys, of course, is just apply the third root. Or in other words, x minus 1 cube is equal to 0. This is like, this is like x minus 1, x minus 1 times x minus 1 times, x minus 1 equal to 0. All right, because this is a product, this is a product, right? This is a product. So then, because it's equal to 0, then either the first factor is 0, or the second factor is 0, or the third factor is 0. So either the x minus 1 is 0, or the x minus 1 is 0, or the x minus 1 is 0, right? So so it's like x minus 1 is 0, or x minus 1 is 0, or x minus 1 is 0. Okay, so as you can see, well, x minus 1 is 0, of course, that will be x equal to 1. Same thing here, right? And the same thing here. So, you know, so the x equal to 1, it's actually 3 times solution. It's not just one time, it's 3 times solution. It's just one solution, but it's 3 times solution, right? So x equal to 1 is 3 times solution. And that's, again, it's just because of the cube, right? This is just because of this cube. Okay, so then x equal to 1, the solution x equal to 1 is of multiplicity 3, right? So this is, so x equal to 1 is of multiplicity 3. And again, it's multiplicity 3 because that's exactly the exponent, right? Or the power of x minus 1. Now, if you have like, so third example, if you have like, let's say x minus 2, let's say cube times x minus 4 square equal to 0. Okay, and you want to solve this, right? Let's say you want to solve this equation. So again, this is because you have this product, right? X minus 2 cube times, so this is a product, x minus 4 squared equal to 0. So then, because it's a product, then either the first factor is 0. The first factor would be this x minus 2 cube. So this is my first factor. Right, and this is my second factor. All right, so yeah, so then this x minus 2 cube is 0. So either the first factor is 0. Okay, or the second factor is 0, which is x minus 4 equal to 0. Right, so yeah, so then you want to solve x minus 2 cube equal to 0. Of course, you can just, you know, apply the third root. And if you apply the third root, you know, you're going to have x minus 2, just x minus 2 equal to 0, right? So if you apply here the third root and here the third root, right, then you're going to have just x minus 2 equal to 0, right? But at the same time, guys, I mean, x minus 2 cube is equal to 0. This is like x minus 2, you know, times x minus 2 times x minus 2, right? X minus 2 multiplied by itself 3 times equal to 0. So as you can see, x minus 2 equal to 0. It's actually is going to be 3 times the solution, right? I mean, x minus 2 is 0. Of course, then x is equal to 2. So then x is equal to 2 is 3 times solution, right? Because, again, because of this power 3, exponent 3. Right, so this is x equal to 2. This is of multiplicity 3. Okay. Same thing for x minus 4 equal to 0. I mean, you want to solve x minus 4 square equal to 0. You apply, you know, you can just apply the square root. You know, so we have this, I mean, x minus 4 square equal to 0. So then you apply square root. So let me just apply here the square root, both sides. Of course, here you're supposed to have like plus or minus, but because it's 0, plus or minus 0 is just 0. So this is just equal to 0. It's just a 0. And so square root of x minus 4 squared, so square and square root cancel out. So it's just, you know, it's just x minus 4 equal to 0. Right? And x minus 4 equal to 0, then your x is just equal to 4. Now, this solution x equal to 4. So how many times this is a solution of f of our equation? Well, again, it's because, as you can see, there's this, the exponent is 2, right? So this x equal to 4 is actually 2 times solution of our equation, right? This is, and that's again because you have x minus 4 squared. It's like x minus 4 times x minus 4. So, I mean, in theory, you're supposed to say, well, either the x minus 4, the first x minus 4 is 0, or the second x minus 4 is 0. But x minus 4 is just the same as x minus 4, right? So they're going to give me the same solution, right? So x is equal to 4. This is 2 times solution. 2 times solution of the problem. And it's just because the exponent is 2, right? Because as you can see, the exponent right here is 2. Okay. Yeah, so the conclusion here, so we have 2 solutions. Remember, we had this x equal to 2, right? And x equal to 2 is actually 3 times solution. It's multiplicity 3. So we have x equal to 2. So we have 2 solutions, right? X equal to 2. It's of multiplicity 3. And then there's this x equal to 4. And x equal to 4. And it's just, it's actually 2 times solution, right? Because, again, because of this square. So x equal to 4, this is multiplicity 3. X equal to 4 is of multiplicity 2, because the exponent is 2. Okay. So you may ask yourself, well, why do we bother ourselves to count how many times are these solutions? Well, the thing is, this multiplicity actually is going to help us to graph our function f because of the following. So we have the following claim. So remember, x-intercept is just the intersection of the graph with the x-axis. Now, if the multiplicity of an x-intercept is even, so if the multiplicity of an x-intercept or a solution is even, okay, then the graph of f, the graph of f of x is going to touch the x-axis because you have an x-intercept, x-axis, and then it's going to turn around. And so we have actually the following situation. So let's say here's the graph of f. Let's say this is your x-intercept right here. This is my x-intercept. Okay. And let's say the multiplicity of this x-intercept is even. Okay. With even multiplicity. Okay, so what happens, guys, is that so your graph, you're supposed to to join this x-intercept because this is that's one point of your graph, right? But so the graph actually is going to touch the x-intercept, okay, because it's a point of the graph. But then the graph, it won't cross the x-axis. It's going to just turn around here, right here, okay? So it doesn't cross the x-axis. So that's what I mean by touch the graph's going to touch the
Professor, can you please bring your screen down a little bit?
Yeah, sure. You mean like this?
No, I mean up.
That down. Okay. Oh, okay. You need the conclusion of the previous example?
No, before the conclusion.
Before the conclusion. Okay, I'm sorry.
Okay, I got it. Thank you.
All right. So yeah, so now if the multiplicity is odd, the graph actually is going to cross the x-axis. So if the multiplicity is odd, the multiplicity of the x-intercept is odd, okay, then the graph f crosses the x-axis. So I'm going to cross the x-axis. Okay, so in other words, so we have the following situation. So where, so I have my x-intercept. So this is my x-intercept right here, but the multiplicity of this x-intercept is odd. Okay, with odd multiplicity. Okay, so what's going to happen is that your graph of f, this is f of x, of course. So the graph of f is going to touch your x-intercept, of course, because that's a point of the graph. But then it's going to cross the x-axis. Okay, so we're going to go all the way down. Okay, so it's going to cross your x-axis. Okay. Yeah, so yeah, just keep in mind, so if the multiplicity is even, you're gonna touch the x-intercept and turn around. If the multiplicity is odd, then your graph is gonna cross the x-axis. And again, the multiplicity is just the number of times your x-intercept is a solution of the problem, right? And it's just given by the, it's just given by the exponent. All right, guys, so that's for that's for the x-intercepts. So I guess that's all we need to graph our polynomials. So in general, so if you want to graph a polynomial, okay, now, steps to graph a polynomial. So first, you need to find, or you need to determine the behavior at infinity, the behavior of the polynomial at infinity. And this is just because of the, just from the degree and the sign of the leading coefficient. So you can determine the behavior of the polynomial at infinity. At infinity. And then you have to find, as a second step, you need to find the x-intercepts, of course. Find the x-intercepts. And also the multiplicity of the solutions. Okay. And then finally, you can also find the y-intercept. So if we find the y-intercept, again, the y-intercept is just you plug 0 in the function f, right? So just replace x with 0. So just evaluate f of 0. That will be your y-intercept. Evaluate f of 0. Okay. The first step, Saul, the behavior at infinity. Yeah, I'm gonna do an example now. But that's the that's what we discussed the Wednesday last week. I don't know if you attended the lecture last week, but that's what we discussed Wednesday last week. The table we had in the beginning of the lecture with the 4 different cases, this one here. So we're gonna use this table. You're gonna use this table to determine the behavior at infinity. Yeah, I'm gonna show you an example how it works. I mean, it's not. I mean, once you have this table, then it's not really hard to know the exact to determine the behavior at infinity. So let me show you with an example. Yeah, no problem. So I mean, yeah.
So hold on, hold on. Can you please bring the screen down a little?
Down. Okay. Is that okay?
No. More.
A bit more. Okay. Sorry. Yeah. So I'm gonna show you with an example how to graph these polynomials using the behavior at infinity and the x and y intercepts. Again, the graph of your polynomial doesn't have to be perfect. It's just you need to find like the shape, like the general shape of the graph. Okay. Are you done?
Yeah.
Yes. Okay. Perfect. Thank you.
Thank you.
Mm-hmm. All right. So let's do an example. Example number 1. Example. So let's say you have f of x equal to minus x cubed, right, plus 2x squared, right? So first we need to determine the behavior at infinity. Two, we need to find the x-intercept and the multiplicity of the solutions. And multiplicity of the solutions. And then we need to find the y-intercept, and then we're gonna graph f. Graph f. All right, so so for number 1, to find this behavior or determine this behavior at infinity, all you have to do, guys, is to find the degree and the sign of the leading coefficient. So so this is minus x cubed plus 2x squared, right? So the highest power of x is, of course, is 3, right? That's the highest power of x. So degree of f is 3. Degree of f, highest power of f is 3. Okay, and that's odd, of course. 3 is the number 3 is odd, right? This is odd. This is odd, right? And then the leading coefficient, the number in front of the highest power of x. So leading coefficient, leading coefficient. So the leading coefficient is, well, so be careful, guys. Of course, this is negative in front of the x cubed. That's the highest power of x. There's a negative. So this is like -1, right? This is like -1 times, x cubed. So it's -1, which is negative. So this is negative. Right? Now, just remind you very quickly the table right here. Here degree, even, degree, odd. This is a leading coefficient here is positive. Here, leading coefficient is negative. So we have these 4 graphs right here. And then we have so this is the first case. The second case, we have something like this. The third case, we have something like this. And the last case right here, we have something like this, right? So in our example, guys, the degree is odd, right? 3 is odd. The highest power of x is odd, right? So we are in this column right here because the degree is odd. Now, the leading coefficient is negative. It's -1, right? So if it's negative, so we are in the second row, right? In the second row. So degree odd, the leading coefficient is negative. So then the behavior at infinity would be this one here, right? Degree odd, and the leading coefficient is negative. So the answer, to answer this question, all you have to do, guys, just draw this graph, like here on the left. So you have something here in the top, and on the right, you have something here, right here in the bottom. So that's the answer. Okay, so this is the behavior of f at infinity. All right, and of course, I mean, of course, you need this table, right? That we discussed last week. Or instead of the graph, you can also say, I mean, it's up to you. Or you can say, instead of the graph, you can say, well, if my x is, remember guys, here's your x. If your x is at positive infinity, then, so if when x is approaches positive infinity, then y approach a negative infinity, right? Your y. So if x is right here, then the image y is going to be at negative infinity. So y approach negative infinity. And if x is at negative infinity right here, the image would be, y would be at positive infinity, right? And so when x is negative infinity, y is going to be positive.
Professor, I have a question.
Yes. I'm going to just erase this.
For the leading coefficient.
The negative, that's because it's a minus x cubed. We had, where is it? So it was minus x cubed, right? It was minus x cubed. And minus x cubed, that's like -1 times x cubed. That's why my leading coefficient is negative.
Thank you.
And this is, yeah, so this negative, this is like -1 times x cubed, right? It's like -1 times x cubed. Okay. So for the answer, guys, I mean, in the test or in the final, it's up to you. You can just graph, so we have like two possible answers here. Either you can say, well, here's the answer, first possible answer, just graph your graph like in the positive infinity and negative infinity, or you can use this notation here with the arrows. X approaches positive infinity, then y approaches negative infinity, etc. Okay, it's up to you. So both answers are correct for me. Yeah. All right, so that's for the behavior at infinity. Now, 2, we have to find the y-intercept and the multiplicity of the solutions, right? So next, the x-intercepts. And don't forget the multiplicity, guys. So, and their multiplicities. Right, so we need to solve, of course, to find the x-intercept. So we need to solve, you have like minus x cubed plus 2x squared equal to 0, right? As I want to solve this is not the quadratic equation. You cannot use the quadratic formula, so you have to try first factoring. There's a partial factor. There's a common factor, as you can see. There's a common factor, right, which is x. And even better than x, we have x squared as a common factor. So we can factor out x squared, right? So here's my x squared times. All right, so if you pull out the x squared, then don't forget this is minus x cubed, right? So this is like minus x if you pull out x squared, right? Don't forget the minus x, and then there's a plus, so this is my plus, and then times 2, right? 2x squared, that will be x squared times 2 equal to 0. All right, so now I got this product, right? This is a product. So we have two factors. This is first factor. This is my first factor. And this is my second factor. All right, so as I said here, this is highest power of x is 3. We're supposed to have like, we expect like 3 different solutions, but let's see how many solutions we're gonna have. First, we have this x squared. So either the x squared is 0. X squared is 0. Right? X squared is 0. I mean, you apply this the square root. You know, you apply just the square root. Both sides, you know, there's a square root. Don't forget the plus or minus. You're supposed to have plus or minus because of the even power, but it doesn't matter because minus or plus or minus 0 is just 0. So then your x is just 0, right? That's your first solution. Now, what's the multiplicity of this solution, guys? Any guess?
It's 2.
2, right? Because it's x squared. It's x times x. You know, so x equal to 0 is actually 2 times. It's 2 times solution because of the exponent, right? So this is so x equal to 0 is of multiplicity 2. Okay. Now the other solution, so x squared is 0, or my second factor, which is, you know, just minus x plus 2 equal to 0. And then, well, as you can see here, there's no exponent, guys. I mean, it's just minus x plus 2. So then you solve, you know, you add plus x to both sides. So your x is going to be equal to positive 2. Okay. And as you can see, this is just, it's just one-time solution, right? As you can see here, there is no power, right? So this is, it's just x power 1. I mean, this is like, you know, this is just x power 1. So this is just one-time solution. So this is x. So this x equal to 2 is of multiplicity 1. Okay. And well, you know, I mean, we're supposed to have like 3 different solutions, but we got only 2. But one of the solutions is of multiplicity 2, right? So that's why, like in theory, we have like 3 different solutions, but like there's one solution which counts for 2 solutions, right? Which is x equal to 0. Yeah, so that's my x-intercept. So the answer to this, the answer for this step, so we got, so the x-intercepts are, so first we have the 0. So we got the 0, and that will be of multiplicity 2. And then we got the x, I mean, x equal to 2, so that's 2, 0, and that's just of multiplicity 1. All right, and then, yeah, and then that's for the x-intercept, and then the y-intercept. The y-intercept. All right, and then for the y-intercept, guys, all you have to do is just to evaluate f of 0 plus 0 in the function f. So that's minus 0 cubed plus, what was it? Plus 3, I think plus 3. I think it's plus 3 or plus 2, sorry. I was, sorry. Yeah, plus 2 times 0 squared, which is, of course, I mean, everything is just 0. So the answer is 0. So then your y-intercept is just 0. You don't need the multiplicity for the y-intercept. You need the multiplicity for just for the x-intercept. So the y-intercept here is just 0. Y-intercept is just 0. Of course, the x is always 0 for the y-intercept. Yeah, so that would be 0, 0. All right. Yeah, so then we can graph our function f. So let's see how it's gonna work. So number 4, the graph. And of course, in this graph, I'm gonna try to use all these informations. So graph f of x. So there's the behavior at infinity, right? And don't forget, so we have the x-intercepts. X-intercepts, we have the 0 of multiplicity 2. We have the 2, 0 of multiplicity 1, right? And then there's a y-intercept, which is it's the same as the x-intercept 0, 0. The y-intercept is 0, 0. All right, so of course, this is supposed to be positive infinity, negative, positive. This is negative infinity. We're gonna need 0, and we're gonna need 2. All right. So first, we're gonna start with first thing to do, guys, is to start with the behavior at infinity. So as I said, the behavior at infinity. So we have the following. We have the following behavior at infinity, right? This one right here. So your graph is supposed to start from the top on the left. So from the top right here, okay, you're supposed to start from here. That's like saying where my x is, when my x is, when your x is at negative infinity, close to negative infinity, or in the neighborhood of negative infinity, your image y, your image y is close to so this is positive infinity, sorry. This is positive infinity, of course. Your image y, your output y is close to positive infinity, right? And then on the right, the graph is gonna be somewhere right here, right? And that's because when your x is at positive infinity, your y is gonna be in the neighborhood or close to negative infinity. Okay. All right, now let's plot the x-intercept. First x-intercept is 0, 0. The second x-intercept is 2, 0. And then you're supposed to plot the y-intercept, but the y-intercept is just the same as the first x-intercept, the 0, 0. Okay, so that's all we have, right? All right, so now let's just join the points here. So we're gonna start from the top right here. So next thing we have is this x-intercept, right? The 0, 0, the origin, right? But then just remember, guys, we said this 0, 0, this x-intercept is of multiplicity 2, right? This is a multiplicity. And 2 is even, right? This multiplicity is even. And when we have even multiplicity, we are not supposed to cross the x-axis. You're supposed to touch the x-axis at the x-intercept, so at 0, 0, and then turn around. So I'm gonna just turn around here. Okay, I don't cross the x-axis, as you can see, because the multiplicity is even, right? So you don't cross the x-axis. Now, next point, of course, is the 2, 0. My next x-intercept is 2, 0, but this is of multiplicity 1, which is odd. And when the multiplicity is odd, you are supposed to cross. You have to cross the x-axis. So here, I'm gonna just cross the x-axis. Okay, and then of course, once you cross the x-axis, then you can just go all the way down. All right. And so yeah, and that will be your graph of your f. So this is your, this is your f minus x cubed plus 2x squared. Right. So again, guys, just don't forget this point right here. This is multiplicity even. So multiplicity is 2. Multiplicity is 2, which is even. So you don't cross the x-axis. Okay. And this one here, multiplicity is 1. It's just one-time solution. So you cross multiplicity is odd. Is 1, which is odd. So you have to cross the x-axis. Okay. Any question, guys? So this is the shape of the graph of minus x cubed plus 2x squared. So as you can see, just with the behavior at infinity and plotting the x and y intercept, okay, you can actually you can graph your f. So here's an exercise for you guys in the last 20 minutes, a couple of polynomials to graph. So exercise. So let's have a couple of functions. First function, function 1. Let's see. Yeah, so f of x so number 1, f of x is equal to x fourth minus 6x cubed, right, plus 9x squared. Okay, number 2, so we have f of x. Let's see. Yeah, so this is just x cubed minus 2x squared plus x. And the last one. So number 4, I'm gonna do some negative. We need some negative. Let's see. Yeah, let's do this. Minus x fourth plus 3x cubed minus 2x squared. All right. So what we need to do, guys, is the following. So first, so 1. So you need to determine the behavior at infinity, of course. The behavior at infinity. Just from the degree and the sign of the leading coefficient. Number 2, find the x-intercepts and their multiplicities. Three and 4, 3 and 4. So 3 find the y-intercept, and 4 graph f. Okay. All right, guys. Let's say you have well, you have 10, 15 minutes. Let's say how much time do you have? Yeah. Okay. Yeah, let's say you have 10, 15 minutes to think about this exercise. So just to remind you the behavior at infinity, guys, all you have to do is just use this table with so for number 1, just use this table. So here degree is even, here the degree is odd. Here leading coefficient is positive. This is positive. Here's negative. And so yeah, This is when it's even, positive leading coefficient, even with negative leading coefficient, odd with positive leading coefficient, and finally odd with negative leading coefficient. Oh, sorry. So this is supposed to be 5. Sorry, it's not 9. I'm sorry about that. So this is supposed to be 5. This is +5. Sorry. So just to remind you again, guys, so this Wednesday, we're going to meet online because of a heating problem in the campus. So, I mean, after this exercise, we are done actually with this section 2.3. I think I'm gonna jump to the section 2. Rational. I want to discuss rational functions. That'll be the section 2.5. Rational functions, and then I want to discuss section 2.6, solving inequalities. And then, guys, it depends on how much time I'm gonna have. I will, of course, we need to do the exponential and chapter 3, the exponential and logarithmic functions, and then chapter 4, the trig. Because we have like, I would say like probably 1 month left, you know, and we don't have much time. So, and I want to really cover chapter 3 and 4. So I'm gonna probably jump to section 2.4. I, I don't think it's really important. It's not really that important, but yeah. So yeah, I think I'm gonna jump to section 2.4 to the section 2.5.
Hey,
Hey, Lewis.
hey, yeah,
Yeah,
I just
yeah,
wanted to confirm the email. You said since there's a heating problem, we
yeah,
won't be
yeah,
going physically on Wednesday?
yeah. We're gonna meet online on Wednesday. Yes.
All right, sounds good.
And actually, I don't know when they're gonna fix the problem. So there is a chance that also next week, I mean, probably for the next 2 weeks, we're gonna again meet online on Wednesday. But I don't know yet when they're gonna fix the problem. But yeah, for sure, this Wednesday we're gonna meet online. Yes.
Okay, got it.
And I think this is not just for my class. I mean, this is for all in-person and hybrid classes. So, I mean, if you have any hybrid or in-person class, this week you're supposed to meet online, not in person. I think I'm not sure if we can even enter the campus now. Yeah. Anyway. Um, if you didn't get your test grade, guys, I mean, if you for some reason you didn't attend the lecture, I mean the lecture last week, Wednesday last week. If you didn't get your test grade, please send me an email. I'm not sure if I can scan your test, but I mean, probably next time I'm gonna meet you in person, I can give you your test. So I think for graphing polynomials, guys, I would say the main thing or main new, I mean, the new thing here is that this where you have to, the first step where you have to determine the behavior at infinity. I mean, once we have the behavior at infinity, and then with the x-intercepts, then you can graph your function f. But you will see, like in the next section, when we graph will graph rational functions, I would say it's more tricky. Rational functions are more complicated. Rational functions, actually, they are like quotient of polynomials. So you're gonna have like fractions. Quotient of functions. It's kind of tricky. We'll see there are like more steps than graphing just polynomial functions. But for polynomial functions, it's just with this behavior infinity, then you are, I think you are good to go. You can graph your function. Okay, there's like just 1 minute left. You know what, guys? I guess I'm gonna stop here today because obviously I don't have time to go over this exercise. And so I will discuss this exercise in the next Wednesday. And then, as I said, we're done with this section. So then I'm gonna jump to the section 2.5. All right. So thank you for listening, guys. I will see you online on Wednesday. All right.
All right. Take care.
Take care. Take care, everyone.
Professor.
No, next test. No,
I have a
so no,
question.
there's no. Sorry, I have a question in the chat. I'm sorry, Beja. But before that, I have a question in the chat. So no, tomorrow there's no test. No, so there's no test. No, next test is like first right after Thanksgiving, like the first last week of November, first week of December. Yeah. Yes, Bejan. Yeah, please go ahead.
Okay, but on Wednesday we're going to go through this before we start the other topic.
Oh
right?
yeah. Of course.
Okay, thank you.
Thank you, Nahara. Have a good day too. See you next time. Thank you, guys. Ciao.